Welcome back to Dr. Liu's VCE Chemistry channel. Today, we are breaking down the fuel and heat of combustion questions from the 2018 VCE Chemistry exam. As I go through this, please feel free to correct me if you find any mistakes. All feedback from teachers, parents, and students is greatly appreciated. Renewable energy comes from natural sources like the sun, wind, water, and geothermal heat, which are constantly replenished. Unlike fossil fuels, these sources will not run out. For example, petroleum gas is not a renewable energy source because it is not constantly replenished. However, biodiesel is renewable because it's derived from plant and animal materials that are continuously replenished. It's also important to remember that electricity can be generated from various sources, not just by burning coal, including fossil fuels, solar power, and nuclear energy. While biogas is a renewable fuel, burning it still releases carbon dioxide because it contains carbon. Coal seam gas, which is primarily methane, is a natural gas found in commercially viable quantities near certain coal deposits. It is commonly used to generate electricity, and when burned, releases fewer greenhouse gases than coal. A significant issue with coal seam gas extraction is that the large amounts of water released are often polluted and cannot be used directly for farm irrigation. It is also important to note that coal seam gas is extracted from coal seams or ore itself, and is not a form of renewable energy created from decomposing plant and animal material. The total enthalpy change of a reaction is directly proportional to the amount of substance consumed. Therefore, to determine this value, one must multiply the heat of combustion by the stoichiometric coefficient of the compound in the balanced equation. The heat of combustion of methanol is available in the data book. For instance, a coefficient of 2 for methanol indicates that the total enthalpy change for that reaction is twice the standard heat of combustion. To identify the right fuel to heat 1000 g of water from 25.0 degrees Celsius to 85.0 degrees Celsius, we must calculate the energy absorbed by the water, and then find the corresponding amount of energy released by the fuels. Using data book values for the heat of combustion, we can determine that 0.282 moles of methane releases the exact same amount of energy. Petrodiesel is a nonpolar fuel that relies solely on weak dispersion forces between its molecules, making it less hygroscopic and less viscous. Derived from non-renewable fossil fuels, it is also less biodegradable than its counterpart. In contrast, biodiesel is derived from renewable plant and animal sources. Its molecules contain a polar carbonyl group, allowing for both dispersion forces and stronger dipole-dipole attractions. This makes it more hygroscopic, more viscous, and more biodegradable. To determine the mass of pentanol, in tons, needed to release 10,800 mJ of energy, we first need to calculate the number of moles of pentanol required. Then, we can convert this molar amount into a mass in grams and, finally, into tons. A chemistry class conducted a practical investigation to determine the calibration factor of a calorimeter using two different methods, electrical and chemical. Each student compared the results from the two different methods and presented the investigation as a scientific poster. Electrical method for collecting calibration data. Add 100 milliliters of water to the calorimeter. Stir the water and record its temperature every 30 seconds for several minutes. Apply a voltage of 6 V for 3 minutes. Stir throughout and record the temperature every 30 seconds. Record the voltage and the current while the water is heating. Once the power is turned off, continue to stir the water and record the temperature every 30 seconds for a further 3 minutes. Chemical method for collecting calibration data. Measure 3.0 g of KNO3 accurately. After completing the electrical calibration, add the KNO3 to the calorimeter. Stir and record the temperature every 30 seconds. The student A's aim is to compare the calibration factors obtained from 2 different methods. The calibration factors were found by recording the temperature change of a solution resulting from the addition of a measured electrical input and from potassium nitrate dissolving in water. Based on it, we find the independent variable and the dependent variable. Independent variable, the calibration method, method 1, electrical input versus method 2, potassium nitrate dissolving in water. This is the variable that the experimenter is changing or controlling. Dependent variable, the calibration factor itself. This is the value that is being measured and recorded for each method. The student is trying to see if the value of this factor changes depending on the method used. Therefore, the calibration method is the independent variable, and the calibration factor is the dependent variable. The student is not measuring the method itself, they are measuring the factor that results from using each method. Systematic errors, or bias, are consistent and repeatable errors that consistently shift measurements away from the true value. These errors can stem from faulty instruments, incorrect calibration, or procedural flaws. In the context of the systematic electrical method, these errors could arise from calibration inaccuracies, imprecise voltmeters and ammeters, or issues with the electrical connections. If the temperature isn't stabilized before adding the KNO3, the results will be inaccurate and difficult to repeat because the initial temperature change is unpredictable. This lowers the reliability of the results. To improve reliability, we should wait for the temperature to stabilize and have different experimenters repeat the experiment. Student A and Student B reported different results. One reason for this could be that Student A's higher maximum temperature, 25 degrees Celsius, compared to Student B's, 24 degrees Celsius, may have been caused by Student A turning the power off at a later time. Similarly, the difference in the time it took to reach the maximum temperature could also be attributed to Student B turning the power off earlier. Furthermore, the use of different calorimeters likely introduced varying levels of energy absorption, which would also account for the discrepancies in their data. When using the chemical method to determine a calibration factor, we first calculate the number of moles of potassium nitrate used. This allows us to calculate the energy released when the potassium nitrate dissolves in water. Finally, by using the measured temperature change, we can determine the calibration factor. This section is worth 15 marks, accounting for 12.5% of the total marks for the examination. It focuses on the properties of fuels and their combustion. Multiple choice questions, 6 marks, questions 3 and 5, examine different types of fossil and renewable fuels, including petroleum, gas, coal seam gas, and biodiesel, and their defining characteristics. Question 23 compares petrodiesel and biodiesel, with a focus on why petrodiesel might be preferred for a transport company due to its lower hygroscopicity, lower viscosity, and lower biodegradability. Question 14 requires the calculation of the total enthalpy change for a reaction, given the heat of combustion per mole. Questions 22 and 25 focus on calculating the energy released by fuels and selecting an appropriate fuel for a given task. Short answer questions, 9 marks. Question 9. This question is about calorimeter calibration. It describes a practical investigation where students use both electrical and chemical methods to determine a calorimeter's calibration factor. The question explores the methods used, potential systematic errors, and the limitations of each approach. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.